Hi everyone, my name is Peter Klaas, and in this example I would like to show you a fracturing operation in Houdini using a bit of subs, expressions and dubs near the end of it. First of all, I would like to show you how to generate a fracturing pattern and then the different usages of such pattern. Because sometimes it's not always necessary to go all the way with dubs. You can just use pops or maybe even use a procedural modeling approach. So let's get sort of started. I want to show you a little bit of the end results and a bit of the workflow that we will be using. First of all, as you can see, there's a grid there and it's sort of being split up in a randomly fashion. We will be making a little tool using it for each sub that will split up a grid in this kind of randomly fashion, but with a bit more control over it, so that the user can define the randomness, can define sort of the center point, can define if there is a center point, can define where the center point should be and how many divisions there should be. Then basically from there on we can have an extrusion operation going on every single primitive, and we will be using that extrusion either through DOPS or maybe later on, so as in DOPS it will break apart, or we can use this extrusion operation in combination with a cookie operation, so that we can actually have other objects like this sphere over there, and these other little spheres represent like pieces of the generated geometry, and we can use a cookie operation to kind of bite into that object, so we can kind of break it up. So I'm just going to show this. So basically this is more towards what we're actually going to be doing. So as you can see, the grid is broken up, right, with pieces over there, with the center point over there. There's a certain radius to the center point, so they're not all going through the same center point. The nice thing about this example is that it layers quite well. So as you can see, there's another one over there, and then basically we take it to the next step where we give a random color to every individual primitive. So every individual primitive has got a unique color in floating point. Then we take this surface, the previous surface, sort of the previous step, we triangulate it and we transfer the colors from the random colors onto the triangulated geometry. So now we've got triangulated geometry with different colors sort of broken up into bigger chunks, and it's going to try to average this as good as it can, but obviously because it's triangulated it will give these rough, nice broken up edges. From there on we will group them based on their color and then put them sort of through a for each operation and make them all individual chunks and make them sort of big and maybe with a little inset and a little scaled inwards. Or we can use this sort of fractured pattern and feed it into DOPS as a cloth object and use some forces to blow it apart. Okay, so now I'd like to show you a little sort of combination of different effects. So I'm going to start playing. This is the first example, which is a cloth DOPS example. So all the pieces are sort of broken up and being flown into space. This, however, is a example of procedural modeling where there is a point in space, right, and it's rotating about the origin, and based upon the distance to that point, based upon the distance between that point and every single piece of the geometry, the pieces will react differently. So the extrusion operation that goes on takes the distance to that point into account, and if the distance to the point is really close, as you can see over there, right, it will extrude the point a bit more and it will give it an inward scale. So there is no dynamics in this example at all, and you can just see, come on, and you will just be able to see how the geometry sort of, how the point is moving through the grid. In this example I'm using particles, so I'm actually copying the pieces of geometry onto particles and I'm applying some forces to the particles. The advantage of this is that this is very fast. There is no actual intercollision taking place between the pieces, but there, that doesn't matter in this example. So again, like I said, we don't need to go all the way with DOPS to get this kind of effect going. So you get this kind of cracking pattern. In this example I'm actually using DOPS to break it down. So as you can see, the object is sort of, the pieces are glued together and two spheres are being pushed through it and it starts falling apart. So in the final example I'm using the cookie operation rather, where we get sort of this splitting example. Okay, so this is just a sphere, and it's sort of this extruded pattern of pieces is run through it, the cookie operation is taking place, and it's just falling apart, right? So not much there, no glue taking place, just a fractured object. Okay, so in the next example, in the next video tutorial, in the next lesson, I will show you how to sort of approach this operation of breaking up, approaching the fracture pattern.